solution exists for securing metal-clad cable, often referred to as MC cable, in tight spaces such as attics, particularly when running it along trusses. This involves using a cable saddle featuring a 90-degree bend tab. These cable saddles are specifically designed for situations where accessing the top of the framing member is challenging. The 90-degree bend tab allows for nailing or screwing the saddle from the side of the truss, effectively trapping the cable on top. Key features of these cable saddles include firstly, a 90-degree bend tab for simplified side installation, secondly, UV-resistant plastic construction ensuring durability for both indoor and outdoor use, and thirdly, availability in various sizes to accommodate different cable diameters. When installing these cable saddles, follow these steps. 1. Hammer or screw the tab into the side of the truss at the desired location. 2. Route the cable through the saddle and over the bent tab. The benefits of using these cable saddles are numerous. Firstly, they offer quick and easy installation even in confined spaces. Secondly, they securely trap the cable without causing damage. Thirdly, they are compatible with a wide range of cable sizes. Fourthly, they provide a neat and professional appearance to the installation. These cable saddles are readily available at electrical supply stores and from online retailers. When selecting cable, always refer to the National Electrical Code, commonly known as the NEC, for proper selection and installation methods. For example, NEC Section 310.15 and its associated tables provide guidance on ampacity ratings for conductors based on factors such as insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. Ampacity refers to the maximum current in amps that a conductor can carry continuously under specified conditions without exceeding its temperature rating. Additionally, NEC Section 330 pertains specifically to metal-clad cable, outlining its permissible uses, installation requirements, and ampacity. Proper grounding is crucial in electrical systems to ensure safety and prevent electrical shock hazards. Grounding involves creating a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. NEC Article 250 provides comprehensive requirements for grounding and bonding. Bonding refers to the connection of metallic pots to form an electrically conductive path, ensuring that all metallic components are at the same electrical potential. This helps to minimize voltage differences and prevent dangerous touch voltages. When working with electrical systems, it is essential to use appropriate personal protective equipment, commonly known as PPE, such as safety glasses, gloves, and insulated tools. Always de-energize circuits before working on them and verify the absence of voltage using a reliable voltage tester. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit while work is in progress. The electrical work should only be performed by qualified and experienced individuals who are familiar with the NEC and local electrical codes. If you are not comfortable working with electricity, it is best to hire a licensed electrician to perform the work. Improper electrical work can be dangerous and can lead to electrical shock, fire, or other hazards. When running cable through walls or floors, it is important to protect it from physical damage. This can be achieved by using conduit or installing the cable in a protected location. The NEC specifies requirements for cable protection in various situations. For example, NEC Section 300.4 addresses protection against physical damage. Cable should be supported at appropriate intervals as specified by the NEC to prevent sagging or strain on the conductors. Cable ties, straps, or other approved methods can be used to support the cable. Avoid over-tightening cable ties, as this can damage the cable insulation. When making connections, use appropriately sized wire connectors that are listed for the application. Ensure that connections are tight and secure to prevent overheating and arcing. Antioxidant compound should be used on aluminum conductors to prevent oxidation, which can lead to increased resistance and potential failure. The NEC provides guidance on conductor termination and splicing requirements in Section 110.14. When installing electrical equipment, follow the manufacturer's instructions and the NEC requirements for clearances and working space. Adequate working space is necessary to safely access and maintain electrical equipment. The NEC specifies minimum working space dimensions in Section 110.26. Proper labeling of circuits and equipment is essential for safety and troubleshooting. Label circuit breakers, panels, and other equipment with clear and accurate information. Use permanent markers or labels that are resistant to fading or damage. The NEC requires labeling of electrical equipment in Section 110.22. Regular inspection and maintenance of electrical systems are important to identify and address potential problems before they become hazards. Check for loose connections, damaged wiring, and other signs of wear or deterioration. Have a qualified electrician perform a thorough inspection of your electrical system periodically. Consider factors such as voltage drop when running long lengths of cable. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidance on voltage drop calculations in Informational Note Number 2 to Section 210.19 subsection A Number 1. When selecting wiring devices such as switches and receptacles, choose devices that are rated for the voltage and amperage of the circuit. Use tamper-resistant receptacles in areas where children are present to prevent them from inserting objects into the slots. The NEC requires tamper-resistant receptacles in dwelling units in Section 406.12. Ground fault circuit interrupters, commonly known as GFCIs, are required in certain locations to protect against electrical shock hazards. GFCIs detect ground faults and quickly interrupt the circuit, preventing serious injury or death. The NEC specifies GFCI protection requirements in Section 210.8. Arc fault circuit interrupters, commonly known as FSIs, are required in certain locations to protect against fire hazards caused by arcing faults. FSIs detect arcing faults and quickly interrupt the circuit, preventing a fire from starting. The NEC specifies FSI protection requirements in Section 210.12. Surge protection devices, commonly known as SPD, can help protect electronic equipment from damage caused by voltage surges. SPD divert excess voltage away from sensitive equipment, preventing damage. The NEC provides guidance on surge protection requirements in Section 230.67. Smoke detectors are required in dwelling units to provide early warning of a fire. Smoke detectors should be installed in each bedroom, outside each sleeping area, and on each level of the dwelling unit. The NEC requires smoke detectors in dwelling units in Section 760.41. Carbon monoxide detectors are required in dwelling units to provide early warning of carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed in a central location on each level of the dwelling unit. Electrical permits are typically required for electrical work to ensure that it is performed safely and in compliance with local codes. Check with your local building department to determine whether a permit is required for your project. Electrical inspections are conducted by building inspectors to verify that electrical work has been performed in accordance with the NEC and local codes. Schedule an inspection after completing your electrical work to ensure that it is safe and compliant. Consider energy efficiency when selecting electrical equipment and appliances. Choose Energy Star rated products that use less energy and save money on your utility bills. Energy efficient lighting options such as LED bulbs can also help reduce energy consumption. Use timers or occupancy sensors to control lighting in areas that are not frequently used. This can help reduce energy waste and lower your electricity bill. Regularly clean or replace air filters in your heating and cooling systems to improve efficiency. Dirty air filters restrict airflow and cause the system to work harder, increasing energy consumption. Seal air leaks around windows, doors, and other openings to prevent drafts and reduce energy loss. Use weather stripping or caulk to seal gaps and cracks. Insulate your home properly to reduce heat loss in the winter and heat gain in the summer. Proper insulation can help lower your energy bills and make your home more comfortable. Consider installing a programmable thermostat to automatically adjust the temperature in your home based on your schedule. This can help save energy and money when you are away or asleep. Unplug electronic devices and appliances when they are not in use to prevent phantom energy drain. Many devices continue to draw power even when they are turned off. Recycle old electronics and appliances properly to prevent environmental pollution. Many communities offer recycling programs for electronics and appliances. Educate yourself and your family about electrical safety to prevent accidents and injuries. Teach children about the dangers of electricity and how to use electrical equipment safely. Keep electrical cords and outlets away from water to prevent electrical shock hazards. Never overload electrical outlets or extension cords. Use surge protectors to protect electronic equipment from power surges. Have your electrical system inspected regularly by a qualified electrician. Follow the National Electrical Code and local electrical codes when performing electrical work. These codes are designed to ensure the safety of electrical installations. Obtain the necessary permits before starting any electrical work. Permits help ensure that the work is performed safely and in compliance with codes. Use qualified and licensed electricians for electrical work to ensure that it is done correctly and safely. Check the electrician's credentials and references before hiring them. Be aware of the potential hazards of electricity and take precautions to prevent accidents. Electricity can be dangerous if not handled properly. Always disconnect power before working on electrical circuits or equipment. Use insulated tools and equipment when working with electricity. Wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. It is better to be safe than sorry when it comes to electricity. Stay informed about electrical safety and best practices. The Electrical Safety Foundation International, commonly known as SV, and other organizations offer resources and information on electrical safety. By following these guidelines and taking precautions, you can help ensure the safety of yourself and others when working with electricity. Remember that electricity is a powerful force that should be treated with respect. Proper planning, installation, and maintenance are essential for a safe and reliable electrical system. This overview provides general information about electrical safety and best practices. Always consult the National Electrical Code and local electrical codes for specific requirements and guidance. Hire a qualified electrician for any electrical work that you are not comfortable performing yourself. The information provided here is not a substitute for professional advice. Consult with a qualified electrician or other professional for specific guidance on your electrical needs. By taking these steps, you can ensure that your electrical system is safe, efficient, and reliable.